All right, so this is the class notes and exploration, and we're going to do the activity 1 exploration. So this is the top. When you open it, you come here, and so these are our examples. And then if you come down here, you get to the activity 1 exploration. So what I would like you to do on the textbook, you're on page 181, and it says activity 1 exploration, and you're going to do this exploration. So it's saying, I'm just reading it. In the introduction, you investigated the paths of freely falling objects. In this activity, you model these with parametrics. Consider 2 falling objects. One is dropped straight down from a height of 10 meters, and the same instant, the other one is pushed from the same height. So you have a graph on your book, and it has these filled in squares, and it kind of goes down like this, all the way down, and then you have these not filled in squares that are representing the one that's dropped. Okay, so what they would like you to do, it's saying list the points. So on question A, use the graph to approximate the ordered pairs for these positions where X represents the horizontal distance and Y represents the vertical distance. So they both started at 10 meters. So I'm going to put in the point 0, 10. I'm going to just go ahead and use like orange. So that would be this point. And then if I look at my second point, that would be, it's also at 0, we'll say like 9.8, right? And then if I look at my third point, open point that's down, it's really the second one I can see because the first point is an open one followed by it because they're both at 10. So this one is like at 9, 0, 9.1, and so on. So I would like you to pause right now and just estimate. There's no right or wrong in this. You're just estimating. Okay, so pause and fill it in and then check. So I'd have 0, like 8.2, and then I'd have 0, like 6.9, and then 0, like 5.1, and 0, 2.9, and the last one would be at 0, like 0.5. Okay, and so that's all these squares going down the side. So now I'm going to do the closed ones, and if you look, these are the same levels as I go down. So as I go down, these blue filled in ones are at the same levels as the other ones, so my Y's are going to be the same, but what's changing is each one of them is going by like looks to me like 0.2 if I go down the page, right? 0.2. So this is so my first one's at 0, 10, and then at 0.2, 9.8, and so on. So you're going to fill in those points the rest of the way. I'll let you pause and fill them in because this is your exploration that I'm going to kind of help you work. But if you don't pause and do some of this on your own, you're going to be confused. Okay, so I turn the page now to page 182. Okay, and it's question B. It says record the values from part A with a spreadsheet. So I made the spreadsheet for you. So if I do the dropped item, I'm going to go back to using orange so we know. So I have 0, 10, that's where it was here. And this was at 0, 9.8, 0, 9.1. Why in God's green earth they didn't just have me do this to begin with, I don't know. But we're just doing this. 0, 5.1, 0, 2.9, and 0.5. So go ahead and do the other one. I'm going to do it in blue. So now I have 0, 10, and I have 0.2, 9.8, and I have 0.4, 0.6, 0.8, 1, 1.2, 1.4, and then I'm filling in my 9.1, my 8.2, my 6.9, my 5.1, my 2.9, and my 0.5. So those are all of my points as I'm going down. Okay, so I have my table made. So my next question says, find the horizontal change of the object at rest and the horizontal change of the one projected vertically. So if I go back up here, my object at rest, I'm now just looking at my horizontals. That's what they're wanting me to do in question C. They're wanting me just to look at the horizontals. So this one is easy to do. If my first one, the one at rest, it just stays 0 all the way down. I don't even need their stupid formula. It's 0. So what is the average velocity in the x position, my average velocity change on C2 is just 0. Okay, and so now let's look at the next one. So it wants me to look at my change, my distance. All of these are 0.2s. Okay, it stays constant. So I'm going to just write 0.2, 0.2, 0.2, 0.2, 0.2, 0.2, 0.2. And so to find my average velocity, if you look at C2, it says change in position. So my change in position would be 0.2 divided by my change in time, which is also 0.2. So isn't my answer to this 1? So my average velocity for whatever was projected is 1 meter per second. I believe these are, meters per second. So this is 1 meter per second, and this one is 0 meters per second. So the third thing, I would like you to try to write the x parametric for this equation. So pause it and see if you can do it. So the x parametric is just going to be x equals 0t because your velocity is 0. Okay, you're starting on the axis. If I go way back up here to the graph, isn't my x for both of these starting at 0? So if you wanted to put 0 plus 0t, you totally could. But I'm starting on the axis. So this one is just going to be y equals 1t because I'm moving at 1 meter for every second. Okay, so now d is a little bit different. So I'm going to take and I'm going to use like this color. D is a little bit different because now it wants the vertical change of the original ones. Okay, the nice thing about D, so it is different. I'm going to have some issues here, but if you look at those tables, they should be the same. So what is my change between the first 2 points? I got about 0.2. So I got about 0.2, but it's going to be the same for both of them, 0.2. Okay, and then if I look at the next one, what's my change here is 0.7. And if I look at my change for my next one, it's like 0.9. So it's kind of growing. And if I look at my change for the next one, it's 1.3. And if I look at the change for the next one, is that a 6? Yeah. So that's 1.8. So it's just growing as I go. And if I look at the change for the next one, I can't read my numbers, 1.8. So 5.1 minus 2.9, that would be 2.2. And then the last one I believe is 2.7. Okay, so when I do these, I'm going to use my calculator here on my phone so I don't have to go back and forth. Okay, so when I do these things, I'm going to now, it says calculate the change in the position. So I want the velocity. So it was 0.2 divided by 0.2 because that's my change. So my 0.2 divided by 0.2. Oops. Each of these have changes of 0.2. So I'm going to do 0.2 divided by 0.2. So my answer is for this first one, and these are going to be the same, is 1. And then I'm doing, my next one is 0.7 divided by 0.2, and it's 3.5. And then my next one is I feel like I did that one wrong. Let's look. So this was 0.2, this was 0.7. Oh, yeah, that was 0.9. That's right. Okay. So 0.9 divided by 0.2 is 4.5. And then my next one is 1.3 divided by 0.2 is 6.5. And then my next one is 1.8 divided by 0.2 is 9. And then 2.2 divided by 0.2 is 11, and then 2.7 divided by 0.2 is 13.5. So these are going to be the same. So we're going to figure those out. That's my change in velocity. So it's getting faster as it falls, which makes sense. Okay, so now to find acceleration, you're going to take, and that's on there, is your change in velocity. So I'm going to use a different color now. My change in velocity. So 3.5 minus 1 is 2.5. I'm sorry, I can't get my calculator to work. Oh my gosh, 2.5 divided. Okay, so, but now my change is I'm looking between these two, so between 0 and 0.4. So I'm going to take 2.5 and divide by 0.4, and I get 6.25. And then I'm going to take 1 and divide it by 0.4, and I'm going to get 2.5. And I'm going to take 2 and divide by 0.4, and I'm going to get 5. And I'm going to take this one right here is 9 minus 6.5 is 2.5 again, which is 6.25. And then I'm going to do 2 divided by 0.4. So these are a little more constant. And 2 would be another 5. So and these are going to be the same. So 6.25, 2.5, 5, 6.25, 5, 5. So the next question, if you turn the page, says average velocity. So if I do my average acceleration, I'm going to add these up, 6.25 plus 2.5 plus 5 plus 6.25 plus 5 plus 5. So I got 30 for my total, and there's 1, 2, 3, 4, 5, 6 divided by 6, and my answer is 5. Okay, so my average acceleration is 5 meters per second because we did the seconds twice. And so it says on part F, compare your average acceleration to a negative 9.8, your answer from part E. So if you look at this is about half of gravity. Gravity is 9.8 and 5 is about half of that. Half of gravity actually is a negative 4.9. But we got very close just eyeballing something. So if you look in the textbook under G says that to find your y equation, you always take half of gravity. So I'm just going to do that instead of doing 1/2 g squared plus the starting height. So if I look at this, then my x and my y, so, they want the x of t, right, a function? Oh no, these both should be y. So my y of t for both of these, for the one that was dropped, is going to be a negative 4.9 t squared minus 10, plus 10, because I started at 10. And my y for the one that was pushed is going to be a negative 4.9 t squared plus 10. So your y's are going to be the same whether it's dropped or whether it's pushed. And so these are my answers, okay? And so this is our activity 1. We kind of talked about how to do these. And then I'm going to have you do the notes with me, and then you'll have time to work.